Today we're looking at LeetCode Problem 83, remove duplicates from sorted list. Given the head of a sorted linked list, delete all duplicates such that each element appears only once. Return the linked list sorted as well. Example, we have a linked list with 1, 1, 2, 3, 3 and null. And we can see once it's been processed it goes to 1, 2, 3 and null. The approach that we're going to be taking is the in-place linked list modification using a single pass. It has a time complexity of O of n and a space complexity of O of 1, and it's the optimal solution to this problem. Now let's walk through an example. We have the nodes 1, 1, 2, 3, 3 and null. Step 1. We want to create a current pointer and start it at the head. Current is equal to head, so let's put current pointer here. And step 2, we want to loop over each node while current and current.next is not null, applying the following logic. So if current.val, which we can see is 1, equals current.next.val, which we can also see equals 1, we need to set current.next equal to current.next.next. So let's update this, and we'll check if current.val, which is 1, equals current.next.next.val, which we can see is equal to 2. They're not equal, so we'll set current equal to current.next. Then again we check if current.val, which is 2, equals current.next.val, which we can see is 3, so that's not true. We set current equal to current.next, so we'll update the current pointer, pointing at 3. And then we need to check if current.val equals current.next.val. Current.next.val is 3, 3 does equal 3, so set current.next equal to current.next.next. So current.next is now equal to null, so break out of the while loop. And then finally, step 3, return head. Thank you very much for watching, it's as easy as that. Why not pause the video and try to implement a solution yourself? If not, stay tuned for my solution next. Now let's look at LeetCode Problem 83, remove duplicates from sorted list. Given the head of a sorted linked list, delete all duplicates such that the elements appear only once. Return the linked list sorted as well. And we're given two examples. Example 1, we've got 1, 1 and 2. Once it's been processed and removed the one duplicate, then we get 1 and 2. And in example 2, we've got 1, 1, 2, 3 and 3. You can clearly see that 1 is a duplicate and 3 is a duplicate. So once it's been processed, we can see that we're left with 1, 2 and 3. So there's three sort of edge cases that come to my mind here. Edge case number 1 would be we are given a empty linked list where head is equal to null. So our solution is going to need to handle that edge case. There's another edge case that I can think of, which is where every number is the same. For example, we could have a linked list which is 1, 1 and 1. So in that scenario, we would want to return just the first occurrence, the first node with that value. So the new process linked list would be 1. And then another edge case would be where there is no duplication. And in that scenario, we would want to return exactly what the input was as the output. There'd be no modification to the linked list. So the approach that we're going to take today is called in-place linked list modification using a single pass. It's a bit of a mouthful, but it is the optimal solution to this problem, and we're going to solve it using JavaScript. So the first thing that we're going to do is we're going to hold the current position. So let current equal head, because we obviously start at the head, and then we want to loop over all of the nodes in the linked list. So we want current and current.next, so we need to make sure that they're not null, because if they are null we need to break out of the loop. So then we check if current .val equals current.next.val. If they're the same, it means there's a duplicate, so we want to set current equal to current.next.next. which means we're skipping over the duplication that we've got there. Else we want to set current equal to current.next. And then once either current or current.next has gone to null, we know that we've got to the end of the linked list. And then we just simply want to return a modified linked list, which is attached to head. So we just want to return head. And run that, see if it works. It doesn't. Why doesn't it? So current and current.next is current.next. Cool, and then we'll submit it and see if it passes the test. It does. It apparently beats 73.5% of submissions for runtime, and it beats 27.7% for memory. The actual runtime complexity is O of n. Obviously, it hits every node in the linked list, so it changes as the linked list grows and shrinks. And the memory usage is just O of 1. And this is the optimal solution to the problem. Well, thank you very much for watching the video. I hope that this has clarified the solution for you. If you like the video, please click like, and if you could subscribe, that would be a huge help. If there's anything that you'd like to see in the future or any recommendations that you've got for me, please leave it in the comments below and I'll get right back to you. Thank you very much for watching and good luck with your coding.